Hi, my name is Lily Adelsik, and this is my Physics 2211 Lab 4 on oscillations. So the goals and findings for this lab were to examine the energy changes involved in an oscillating mass on the spring, and then using a given video, we would record and plot the energy changes that the model computes, and compare the predicted motion and the observed motion in both the x and y directions. For our findings, we were able to find the energy changes for the ball on the spring system, and we were also able to calculate the oscillation period for both the x and y position data. So here are key concepts and fundamental principles for this lab. We are using Newton's second law and the momentum principle again. The momentum principle within the iterations and the code to update the velocity and position formulas, which you will see in the next slide. And then for forces, we have the gravitational force, the spring force, and you'll also be able to see those formulas. And then we are using the energy principle and the different forms of energy of kinetic, gravitational potential, spring potential, and our total energy. And you can see all of these equations here. And for this lab, it is important to recall how to take a unit vector by dividing a vector by its magnitude. For diagrams of the spring, I have two diagrams here. The one on the left is for a spring that is compressed, and the one on the right is for a stretched spring. And we can see that there's always going to be a force that points downward due to gravity, and that the spring force is going to be parallel to the spring. So for the compressed spring, it's going to point down, and then for the stretched spring, it is going to point up. For the initial conditions, based off a video and tracker, I found the initial position to be negative 0.113, negative 0.632, 0 meters in the x, y, and z components respectively. For initial velocity, I found it to be 0, 0, 0 meters per second, so just 0 meters per second for every component. For the mass, I got 0.5 grams. For the initial length of the spring, I got 0.127 meters. And for the change in time, I got 1.524 seconds. So for my glow script code, I put in the initial conditions, which are at the top. So we have the ball mass, and then the initial position, and initial velocity. And then down near the arrow, I use the equations for the kinetic energy, the gravitational potential energy, and the spring potential energy, and the total energy. Continuing with the code, this is in the iteration. So up here we have the force due to gravity and the spring force, and then we sum these to find the net force. Then at the second arrow, I applied the momentum principle, and I used the position and velocity update formulas to update the values for these. And then I also used that to update the spring position values based on where the mass's position was. And then at the last arrow here, I was using kinetic energy and gravitational potential energy and spring potential energy to find the total energy, again using the equations from the beginning. So here are the results for total energy. We can see we have the gravitational potential energy in red, the spring potential energy in green, the kinetic energy in blue, and then the total energy in orange. So for our observed versus predicted graphs of position versus time, they're split into x position and y position. And we can see both of them follow the predicted pretty closely. The x position does shift a little as time goes on, which is likely due to the fact that we use the y position period for the initial value, which we can calculate the x position period later on, which probably would have solved this problem. And then for the y position, we can see that they're just all slightly off in the height, which is most likely due to a lower quality of the video, and or just general problems with calibration and data gathering. So what does this mean? Is the energy principle satisfied? Yes, it is. So no work was done on the system, so the total energy should have been 0, and then we saw in our total energy graph that it did end up being 0 because the gravitational potential energy and the spring potential energy counteract each other. And then what I was saying beforehand, back on the last slide about updating the periods based on the x and y position, so I found the x position period to be 1.6383 seconds and the y position to be 1.5149 seconds. And so if we would have used this x position period, then it probably would have made our last set of graphs more accurate. Thank you for watching my physics lab, and I hope you have a great day.